Hi, my name is Ronit Mukherjee and I'm an applications engineer with Go Engineer. In today's quick tip video, I'm going to be showing you an integrated analysis, basically joining our flow simulation and static simulation. For this case study, we have a thermoelectric cooler. In this case, we've got a heat sink and I've got another cold body. So the idea is heat is being absorbed from the cold side and rejected from the hot side, and there are these little solder joints that are connecting this assembly together. The idea behind this case study is to understand how these solder joints are behaving and test these solder joints for their strength because of the temperature distribution that's going on between all these bodies. So I've already set up the flow simulation analysis and we've gotten some results out of it. I want to show you how we can bring in this information into our static simulation and test for the strength of these solders. So from the results of our flow simulation study, I can see I get some nice fluid temperature distributions, and I can also get some solid temperature distribution between these solder joints. So as you notice over here, I've got results from flow simulation on the temperature distribution on different bodies. Now the idea is to show you how we can bring in this information into our static analysis or on our simulation standard and test for these solder joints over here. So I'll get back into our SOLIDWORKS software and show you how this is done. So here's my thermoelectric cooler and all my assembly parts along with it. I've already set up the flow simulation study and I've run it. It took about 10 minutes to run, and I've done some post-processing for us over here. So first things first, if I wanted to take this information and plug it into my static study, first thing I want to do is I want to turn on my static simulation option. So I'll go to my SOLIDWORKS add-ins and I click on SOLIDWORKS simulation. And what this will do is this will bring up my simulation tab in our command manager tabs, just like it did, and from here I can set up a new study or any study or work with an existing study basically. So over here I've already set up a study for us, so I'm just going to go in and show you what the setup sort of looks like, and we can do some post-processing on it. So first thing, if you notice, since I'm only interested in the solder joints, what I've done is I've removed everything else. The two plates, the heat sinks, the channel, I've removed everything from my static simulation. And since I'm only interested in these solder joints, I'm just going to run an analysis on these solder joints. So that's the first setting that we did, and after that, for fixtures, what I've done is, for simplicity reasons, I just fixed the top and the bottom plate as it's done in the actual assembly. And now, in order to apply the thermal load from our flow simulation, there's two ways of doing that. First, if you right click on your external loads, you can go to this thermal effects tab or flow effects tab, and if you click on it, it opens up the study property, and it'll take you to the third tab where it's your flow and thermal effects. And over here, either you can input a temperature or bring in temperature from your thermal study, which is your SOLIDWORKS Simulation Professional, and third option over here is temperature from your SOLIDWORKS Flow Simulation. So over here you can kind of browse to where your studies are located, and you can select the result from there, and you click OK to that, and you'll notice it'll have a thermal icon on it. This is basically, it's taking the loads from our flow simulation study and now it's acting on your static simulation. You can get it from here in external loads. You can also get it from get to that place from the study properties. So you can if you right click on the study name, go to properties, it opens up the same window, and again the third tab over here is your flow thermal effects, and you can input the temperature, reference temperature 0 strain, and bring in the studies from wherever it's located on your computer. Once you click OK, it takes it in. It takes in the external load. Last thing we did is we just applied some controls to make sure I have good results in certain areas, and I was able to run this study. So now just looking at some results. So if I double click and look at my first ISO plot that I created, I can notice that the yield strength of this particular material is very low, and we're seeing some really high stress values on the solder joints. So just first, a good check would be, yes, this particular solder joint, they're not adequately designed, and these might be failing in those areas. So we might have to either change the material or change the size or the thickness or anything we need to do to be able to get a correct result. So Going back to the PowerPoint over here, I mentioned we were able to, just recapping everything, I mentioned we were able to run the flow simulation study on this assembly, get the temperature distribution from our results, and then we were able to apply these results into our SOLIDWORKS simulation model, where I isolated everything that I did not need to be a part of this assembly, and I just wanted to test for the solder joint. So everything has been suppressed or excluded from the analysis, and under our thermal options I was able to select what study I'm working with. And once you have that input and you run the simulation, so SOLIDWORKS simulation study, we were able to understand that these areas that are indicated with like red color and the maximum of about 104.7 megapascals, these areas will probably have a high tendency of failure, and we might need to redesign this in order for this analysis to work, or for this model to work. So, well, I hope you enjoyed watching this video. Thank you for watching.